Hi, this is Professor Bill here at WPI, and I'm doing a quick recap of 4-point bending. So for 4-point bending, first thing to remember is the machine, let's say in the case of 4-point bending without a deflectometer, you have your sample between anvils, and this is your load span. This is your support span. And this is your load span. And in the terminology or nomenclature that we've been using, this is L for support span. This is A for the distance to the first loading anvil. This is S, the load span. This is A also, and we have two equal loads, P and P. The total force that the machine measures is 2P. So this load over here is equal to 2P. And that's what comes out of the machine. You're going to get a load displacement curve like this. Now, the sample is going to deflect something like this kind of shape when it's loaded, and this center part here is, and these anvils will go down and these anvils will stay in their place, and this displacement from here to here is the center displacement. But that's not being measured unless you have a deflectometer in the middle. So what's measured is this displacement from here to here. So that's del measured. So this is del measured, displacement measured, if crosshead displacement is used. Okay? And for the bending, plate bending standard for metal plates, that is what it says to use for the ASTM standard. For the ISO standard, it says you have to use a deflectometer and get actual true del C. They will give you different displacements for given loads. So what do you have to calculate? You have to calculate the slope of this curve, K, using linear regression, and that is the bending stiffness. And so that is basically a measure coming out from the data, and you just do regression to get that. The other thing you want to measure is this point right here, and that is essentially where the material is yielding, and that is called that is determined by fitting a line here. So you fit to get your K, your bending stiffness line, you move it over by this amount right here, and I wrote this wrong here. I'm going to call this Q, and this is distance Q. Okay, so Q for the 4-point bending is right here. Q equals 0.002 times A, towards times S, where S equals the support span. Okay, so you take your support span distance, say it's 30 millimeters, you multiply it times 0.002, and that's the distance you move on the x-axis. Then you draw a line, and where it hits the actual data curve, that is called your proof load. And that's point D, and point A is your displacement at proof load. So those are your measurements. From proof load, displacement at proof load, and bending stiffness, you can then make the other calculations that are necessary, which are the bending structural stiffness, EI, the modulus, E, and the strain, which is the max strain. The bending structural stiffness is the moment at the proof load. So for 4-point bending, it is that moment equals, that's your max moment, equals FA over 2. And so it depends what the A is. So that bending structural stiffness is going to be dependent on how you set up the test. It's not an intrinsic property, even though E and I are both intrinsic properties of the material. This can change. So that is if you're doing it using the cross-set displacement. When you do it with a deflectometer, you should get an intrinsic property of the material.